So concept zero, this is about diffraction, right? Diffraction is this notion that waves, if they pass through, say maybe a small opening like this, they'll expand outward like this and fill in the shadows, right? And you can look at this. This is a diagram that's supposed to show that long wavelengths, right, have less of a shadow behind them. Short wavelengths, there's more of a shadow. So short wavelengths diffract less than long wavelengths. Okay, long wavelengths diffract more like this, right? And of course, we know this because if you hear those cars with the giant stereos, as they drive by, you hear from any direction you hear the bass, right? Just fills the entire neighborhood. But it's only when like the window passes by you that you hear all the sort of high frequency stuff, right? So that's what we mean by diffraction. There's an approximate formula, and this is very approximate. And this angular spread is, of course, in radians. Anytime you get something that's like a ratio of lengths, the angle would be in radians. But the notion here is that there's, that angle there, right, here's the B is the length, is the size of the opening here. And then lambda here would be the wavelength. So in this case, it would be the distance here between the waves, right? So anyway, this is just an approximate formula. Let me just do an example for you. Here, 656 nanometer light is incident on a single slit that is a fraction, a little more than 1/10 of a millimeter, right? So what is the approximate width of the spread behind the slit, right? So if we draw this, right, it's like that. There's this thing, right? This light is going to be incident on this, and it's going to spread out with some angle like this. Not nearly as big as we've drawn, right? So these waves will spread out. Not this much, but that's the idea, right? Is that these incident waves will spread out like that, and so we want to find that angle. And so the angle is theta divided by the opening, right? So it's 656 times 10 to the minus 9th meters. That's what a nanometer is, right? And then the size of the opening is 0.12 millimeters, so 0.12 times 10 to the minus 3rd meters, right? That's what a millimeter is, 10 to the minus 3rd, right? So let's try this. 656 e minus 9 divided by 0.12 e minus 3, and I get that the angle is 0.0054666 radians, right? Which is amazingly small, right? And that's our radians, and then how many degrees would that be? Let's see. How do we do that? I think what we do is we divide by 2 pi, so divided by 2 divided by pi, and that gets fraction of a circle, right? And then multiply by 360. I get 0.31 degrees, just like this, right? Okay. Yay.